Given f of x is ax to the n. So it doesn't matter what the function looks like. Guys, it's in the form of ax to the n. So you've got a number, you've got x, or whatever the letter is, and you've got a power. Okay? And this is the stuff that we touched on you would have done last year, and you said to me the other day that you're comfortable with. That if you want the derivative, we simply multiply the power by whatever's at the front. You've still got your x, and you take 1 away from the power. So you drop the power by 1. So if it's positive, simple, 3 becomes 2. If it's negative 3, it becomes negative 4. If it's a fraction, it becomes a smaller fraction. So that's why I just put it all together. I don't care what they look like. The same rule applies all the way through. Now, just notation. F dash x or dy dx. Both mean the same thing. It depends on what you started with. If you start with fx, you do f dash x. If you start with y, you do dy dx. Okay? It just depends on who thought they invented calculus. Two dudes did it at the same time. They both had their own notation. Leibniz and Newton both simultaneously came up with the idea of derivatives and everything. So one uses fx notation, one uses y dy dx notation. Okay. As we said the other day, what is derivative? Gradient, tangent, gradient function. Don't care what the word is, it all means the same thing. Find the derivative. Alright, so let's start with something like that. Now this is another thing too. First principle is what we did the other day with the x plus h, fancy stuff like that. You can do it for all this, but there's no need to do that anymore. First thing I do for these things is make sure that you express the function on one line. So y is 3x squared, can't touch it. 8x, can't touch it. But 1 over x is not in a form that I can use this rule. So 1 over x is the same as x to the power of negative 1. Okay? So try and make everything always look like this, for now. Straight line, change the powers, get rid of roots, etc. Now you're ready. Notation. And guys, a couple of things with your diagnostic tests and the trig and stuff. You've got to know how to do the maths, but you also got to know how to write the maths. And they will be really critical of notations and stuff like that. So, no calculus. You haven't done anything yet. You haven't played with powers. You've just re-expressed things. I can't go any further. Now I find my derivative. So dy dx is, play with the numbers. 2 times 3, 6, x, 2 take away 1, x to the power of 1. I'm noting it there just what you're doing. Obviously you will not write that when you're doing the final answer. Plus 8x. What's the derivative of 8x? 8. Right? 4 re-explanations. Back again, just in case we were filling. You had 1. You had 1 times 8 is 8. You had x. You took 1 away, so you made it to the power of 0. That's what you're doing, technically. And the next one is, you get the plus, because you had negative 1. You brought that to the front, is negative 1. X, take away 1, is negative 2. 6x. Anything to the power of 0 is 1, so you're left with 8. You don't need to do that, but it's just lazy, just for the refreshing people's minds. And then you've got negative 1. This has got a negative power. I now put it back on the bottom line and express it with a positive power. So, line them up, bring your numbers to the front, take 1 away, line it back up again. Everyone happy with the fundamentals of derivatives? Yeah? Playing with the powers. So it doesn't matter how complex it gets. Alright? We're not playing with baby stuff. Let's go. Yeah? So, first thing, express as on one line, powers only. Can't touch it. 5 root x in power form is 5 x to the half. Okay? So square root is the same as power half. Now I'm talking about the cube root of x squared. So what's the power? 2 over 3. Good. From indices and things, remember, inside on top, outside on the bottom. And you do your fraction. So whatever root you are sits on the bottom of the fraction. Because this is really a little 2, but we just don't bother writing it. But with 3, 4, etc. we have to express it. Okay, how do I write 1 on 18x squared in the form that I want?
18x negative 2 delta negative 2.
Okay, so let's be careful. Is it 18x to the negative 2?
Yeah.
1 over 18, because the 18 is a number, you're not bringing it up to the top. The only thing you're moving is this guy. And that's an indice thing that a lot of people get confused about. When you talk about bringing it up and bringing it down, you're only moving the x. Unless the whole thing was in a bracket. Okay? If the whole thing was in a bracket, you'd move the whole thing up and down to the negative. But otherwise, numbers are numbers. You know what they are, don't touch them, just play with the letter. Therefore, dy dx is, we're now ready to do our normal derivative stuff, negative 2 times 18, negative 36, negative 2, take away 1, negative 3, plus 5 times a half. Leave it as 5 on 2. Another thing, just in general, don't mix decimals and fractions. Decimals are for babies. No, we don't do decimals. No, we don't do decimals unless you've got no choice. And it'll be a CAS environment that you use decimals in anyway. The CAS-free environment will be exact answers. Don't go writing 2.5, just write 5 on 2. X, take 1 away from a half. Negative a half. Yeah? Plus 2/3 comes to the front. What's 2/3 take away 1? Negative 1/3. Yeah? Now, negative 2 times negative 1 over 18. Okay, we're going to go positive. We're not real good with our fractions, so we're going to say 2 times 1 on 18 is 2 on 18 for the moment. X, take 1 away, negative 3. Algebra, calculus, algebra. Right? So now we fix. This is the calculus step. When I play with the powers, that's when I'm doing calculus. When I'm manipulating how it looks, is what I just call algebra. So, negative 36 over x cubed, bring the negative power to the bottom, plus, okay, 5 over 2 x to the negative a half. I want to move this. So it's going down under the fraction and it sits next to the 2. Yeah? So 5 top line, 2 bottom line, this guy goes from top to bottom. X to the half. Or if you want, square root. Same thing. Plus 2. 2's on top. 3's on the bottom. The x. I'm moving the x down. Sits on the bottom. Plus 2 on 18. The x goes down with the 18. Now you be careful about the line of your fraction. I'll finish it. Can't touch it. I'm going to write this better, so that's root x. I'm going to write this one better, so it's the cube root of x. Yep, x to the third is the cube root of x. And I'm going to cancel this to 1 over 9 x cubed.